just like you. No, I always want stress like you. I always want stress like you.
Let's go.
Try to let go of all of the nonsense that you put me through. I give it all to you. I do it all for you. Maybe this feeling's overdue. You're uninvited. You wanna hold me close, but I know what you have to. Yeah, yeah, yeah. Why are you hiding? Tell me, what must I do? Come to you, come to you. You're mine, mine, mine. It's right, right, right. It's right, 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 right now. Why are you hiding? Tell me, what must I do? Come to you, come to you. You're mine, mine, mine. It's right, right, right. It's right, 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 right now. Why are you hiding? Tell me, what must I do? Come to you, come to you. I try to let go of all of the nonsense that you put me through. I give it all to you. I do it all for you. Maybe this feeling's overdue. You're uninvited. You wanna hold me close, but I know what you have to. Yeah, yeah, yeah. Why are you hiding? Tell me, what must I do? Come to you, come to you. You're mine, mine, mine. It's right, right, right. It's right, 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 right now. Why are you hiding? Tell me, what must I do? Come to you, come to you. You're mine, mine, mine. It's right, right, right. It's right, 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 right now. Why are you hiding? Tell me, what must I do? Come to you, come to you.
Winter's here, the snow is falling on our car as we drive for miles to that little town called home. Tinsel hangs from every corner of the house, and Christmas lights shine bright through the cold evening fog. And I hear sleigh bells bouncing off the halls as the church choir sings along. I feel my heart melt when you walk through those doors for Christmas. You're all I want. All I wanted was you. Christmas cheer and drinks with friends we haven't seen for a while. Since I've been to that little town called home. Pine tree dressed up with every ornament we got, and stockings hung with overflowing from the top. And I hear sleigh bells bouncing off the halls as the church choir sings along. Feel my heart melt when you walk through those doors. For Christmas, you're all I want. All I wanted was you. 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 And I hear sleigh bells. All I wanted was you. Feel my heart melt. All I wanted was you.
There is a place where you can run free. Time does not exist. Take a chance when the world before us falls under our face. I can't hold on. I can't remain so strong. We have the same old bond, but everything is wrong. My love is gone, but I've been born. I can make it on my own when I'm alone. My love is gone. My love is gone, but I've been born. I can make it on my own when I'm alone. My love is gone. My love is.
Alright, all ya. Good night, good night. Let's see what I can do there.
It's wrong.
Alright, all ya, what you see scene? What's the real scene? Plenty people wanna do plenty things here. We go see what we could do. We go see how much we could do. A man say number theory and thing. I look up thing by you could do that on your own. Them things probably on the remedial playlist on the channel. So scope through the remedial playlist on the channel there. See what you can see what you can do. Yeah, circle geometry is the first thing I'm gonna tackle today. First thing I'm gonna tackle today is circle geometry. Verinda, take your time. Take your time, Verinda. Alright, so I'll be using a lot of my notes. Alright, so all ready? All ready? Talk to me. All ready? Now you're gonna have a little delay from voice reaching all, yeah? It's a slight little delay. Nothing detrimental. Right. Let's see what we can do there. Alright. So that's what we're doing. Going through some basic stuff. Circle geometry really easy, yeah? Real easy. Rajiv, it have matrices videos on the channel. Go and watch them after. Right? That 3 matrices videos that should cover everything you need to know in matrices. Now, let me talk about this thing here, right? We have a circle and it has parts of a circle. So DC is a diameter, AC is a radius, EF is a chord. Now, a chord, it cuts the circumference of the circle. It also cuts the area of the circle. So when a chord cuts the circumference of the circle, we have the minor arc, which is the smaller piece of the circumference, the major arc, which is the bigger piece of the circumference. When a chord cuts the area, we have a segment, minor segment, major segment, one piece big, one piece small. And when we have 2 radii joining together for a piece of pizza, we have a minor sector and a major sector. A tangent to a circle is a straight line that just touching the circle at one point alone. Alright, that is all. Touching the circle at one point and one point only. In this case, the tangent is at C. Now, theorem 1 states that if a straight line is drawn from the center of a circle and it's perpendicular to a chord, it must bisect the chord. We don't use this much, so we will just move on. Use this plenty. A diameter subtends a right angle to the circumference of a circle, or the angle in a semicircle is a right angle. Now, easy thing, as long, first things first, subtend. What does that mean? Subtend means I will be using the 2 ends of a line. So in this case, I am subtending from the diameter. I'm using the 2 ends of the diameter. The 2 ends of the diameter, they must meet at one common point. So in this case, D and C meet at E. From now until forever, if a diameter subtends to the circumference, a 90-degree angle is formed. So you're looking out for a diameter in your circle geometry question. You're looking out for the diameter. Once you see a diameter, this theorem should come to play. Next, the angle subtended by a chord at the circumference of a circle, again subtended by a chord, which means I'm using the 2 ends of the chord and I'm going to the circumference. Standing on the same arc are equal. So if you look at this diagram here, you can see that. Nice, good. So you see the chord is BC, and BC is subtending to the circumference at E and D. But if I just subtend B to E and not forming no angle, C must also subtend to E. So the chord subtends this angle here, and it subtends this angle here. And you're just looking for this general shape in a diagram. the angle made at D and at E are equal. Again, once you see a chord, you're looking for this theorem. Next, this one really easy. The angle subtended by a chord at the center of a circle is twice the angle subtended at the circumference. So again, if you're looking at a chord, you're looking for the kind of, I'm gonna try it a little bit here. You're looking for a kind of thing that looking like this. That's one thing you're looking for in a circle when you see a chord. Another thing you're looking for in a circle when you see a chord is just two triangles, one inside of the other. Homeboy here is 2x, homeboy here is x. So far, chords playing a big part in circle theorems. Next, opposite angles in a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. What is a cyclic quadrilateral? A cyclic quadrilateral is a quadrilateral where each of the vertices are on the circumference of a circle. So in this case here, this quadrilateral, each of the vertices are on the circumference of the circle. Bam shot, cyclic quadrilateral. E plus D supposed to be 180. C plus B supposed to be 180. Two tangents drawn from a circle at a point outside will have the same length. One straightforward. Important 7. 7 is an important one. Angle formed by the tangent to a circle and its radius at the point of contact is 90 degrees. Important. Important. Theorem 8 is one of the harder theorems to use to see in a diagram. The angle formed by a tangent to a circle and a chord. So again, chords coming into play. So the angle formed, let me draw it here. The angle formed by the tangent and a chord. So I'm going to draw the chord. I'm a chord and I'm going to draw a tangent at either B or C. It doesn't, good lord. It doesn't matter where I draw the tangent. It could be at either B or C. So I'm going to draw the tangent at B. Draw the tangent at B. Tangent to the circle at B. So they say that the angle formed by the chord and the tangent, I'm gonna just make it look a little nicer now. Make it up a little bit so everybody could see it. Move me out here. This angle here is the angle formed between the chord and the tangent. There is one angle there, and this is another angle formed between the chord and the tangent. So I'm going to just put a point here. I'm going to put a point here. Good. Good. So I'm going to measure our angle. By all means, this is an angle between the chord and the tangent. It's looking 38.69 is equal at the point of contact is equal to the angle in the alternate segment. So the chord here, let me draw bam 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 bam. Good. Now if you observe, this chord will subtend an angle to the circumference at E. The chord separates the circle into two segments, my minor segment and my major segment. The law states that the angle formed by the tangent and the chord, in this case I'm using the smaller angle here, at the point of contact is equal to the angle in the alternate segment. Now the alternate segment just means the other segment. So if this is my minor segment here, this is my major segment here. So I'll measure C, E, B. See what we get. C, E, and B. 38.69 degrees. Now, if I had used the angle created by BE, remember BE is also a chord. So if I measure this angle here, I get 77.932. BE separates the circle into two segments, the minor segment, which is the one to the right, and the major segment, which is the one to the left. So this is my minor segment here. This is my major segment here. The angle made, or the angle subtended in the major segment, is going to be subtended by this chord at C. So C should be 77.932 as well. So palm shot 77.932. The best way to do these things is to actually see them working in diagrams. Let me check out some diagrams here. Let me pull up a worksheet here. Wrong one. Let me pull up some content. Right, content. Actually, we could use about these same things here. Let me use about this one. We will use about these I have here. Yeah. These should give us a fair example of what we did. Good. So watch this. Let's look at example 6. Before you actually approach a question like this, circle geometry, do bother what I'm asking for. See what theorems you're seeing. First things first, see what theorems you're seeing. So I'm going to ignore the question. Big it up a little bit here. Good. I'm ignoring the question, right? I don't care what I ask him for. I'm going to see what I see in here. First things first, whenever you're writing on a diagram, write the words let. Good. Good work with that color. Write the words let. So let the diagram be such. I can calculate this angle here. That angle will be 180 minus 136. 44 degrees. They never ask me for the angle, but I see and I can calculate it. Next, I'm looking for diameter and I'm looking for chords. That are the two things I'm looking for. I see in a diameter. Does the diameter subtend to the circumference? Yes, it does. The diameter AD subtends to the circumference over here. So homeboy there is a right angle. Okay, cool. Next, do I have any tangents? Brother man, I have no tangent. So I am studying with no tangent business. Do I have chords? I have plenty chords. Does any of the chords subtend angles to the circumference? Just one. DE subtends the angle A to the circumference. And to me, that's it. Next, I seen a cyclic quadrilateral. I seen 4 vertices on the circumference, A, B, C, and D, on the circumference. So I know that how this fella here going to be 180 degrees minus 44 degrees, because opposite angles in a cyclic quadrilateral are sum up to 180. So this could be 136. I check in to see what else I can see in the diagram before I move on. And not seeing anything else. Let me see what the question asks us for. A, E, D. Bam shot. Already 90 degrees. Put your statement. The angle subtended by a diameter to the circumference of the circle is 90 degrees. C, DA, 44 degrees, angles in a straight line, are supplementary. A, B, C, 136 degrees, opposite angles in a cyclic quadrilateral, are complementary. Easy peasy lemon squeezy. Try the next one. Now remember, it will have a little delay between me talking and Ollie reacting to whatever I'm saying. So if Ollie need confirmation on anything, put it in the chat and I will address it whenever we get a chance. All right? Give me a second there. One second, guys. So please, if you all have any thing to ask or anything to ask about what we're doing, please voice them in the chat. All right, next. What I would have asked him before, I just looking at the diagram. First things first, I check and see what I could do. I seen one piece of information given to me, 48 degrees. Next, I'm looking for diameters. I'm looking for chords. I'm looking for if the diameter subtends to the circumference. I'm not seeing a diameter, so me about it. I seen a chord AC. I seen an imaginary chord AB. Now I could join the chord AB, and it's clear that AB goes to O and then goes to C. And that will be, if you all can see it, this theorem here. If I join a chord here, this fella here will be 2x. This fella here is going to be x. I'm watching again to see what I can see. I know that there's a theorem that states that if a tangent is drawn from a point outside of the circle, then the length of the tangents are equal. So AE and BE are equal in length. What else am I seeing here? I am seeing a radius to the tangent there and there. What else am I seeing here? I do have a cyclic quadrilateral. A, C, B, D. Just now. I don't see my cursor. Just now. Nice one. All right, so let me see what I'm asking us for. O, A, E, well, 90 degrees. A, O, B. A, O, B. All right. All right. A, O, B is 2x. So if we could somehow figure out what x is, we could figure out this angle in the middle. I see supposed to have a triangle here. Ishwar, was this in Ishwar? Where is triangle, dear boy? I just rubbing off this to see if I can see something else in the diagram here. I see in $90 degrees. Right. This is 90 degrees here. This is 90 degrees here. The shape AOBE is a quadrilateral. A quadrilateral has 360 degrees. So 360 supposed to be equal to 48 plus 90 plus 90 plus 2x. Rearrange and we get what? We want the 2x, we want the whole angle. The whole angle is 2x degrees. So 2x is 360, take away 48, take away 180, I get 132 degrees. And I can figure out what x is one time. X is 132 divided by 2, which is 66 degrees. ACB, we just now work it out, 66 degrees. ADB, opposite angles in a cyclic quadrilateral are supplementary. So ADB plus x supposed to be 180. So 180 take away 66 is 114. Right, let me do the last one. And then I'll just go in and run through the content in our past paper, right? Alright. So I've seen plenty of things here. Oh, another thing for circle theorems is your alternate and corresponding angles. Those are important. So I've seen a pair of parallel lines here, and the pair of parallel lines is being cut. So I've seen an alternate angle already. I've seen a Z here. So this here is 62 degrees off the bat. That is one. Next, I see in SW is a diameter subtended to A. So this whole thing here is 90 degrees. I could work out this angle here. 90 take away 54 is 36 degrees. I see in, do I have a cyclic quadrilateral here? 1, 2, 3, 4. I do. I have one cyclic quadrilateral. Do I have another? 1, 2, 3. No, I don't. I only have one cyclic quadrilateral. I have a chord subtending an angle to the circumference over here and over here. So these two angles are equal to each other. Theta and theta. This is not a cyclic quadrilateral, guys. It's not a cyclic quadrilateral because this point here is not a point on the circumference. Please don't make that mistake. Alright, let me see what I'm asking us for. FAW. FAW, 36 degrees. They give them the reason why. SKF. SKF. They want this angle here. That will be there's a cyclic quadrilateral here. U and U. U and U. Alright, so U plus U for my cyclic quadrilateral supposed to be 180 degrees. So 54, 180 minus 54 is going to be that angle, which is 126. Again, give them the reason why. All the reasons were up in the video. So go back and pause the video and write down your reasons why. And ASW, ASW. I've seen a triangle here. Angles in a triangle are supplementary. Theta going to be 180 minus 54 minus 62, 64 degrees. So this here will also be 64 degrees. You could have also used this, I guess. Nah. Alright, let me see what other things I could show you for circle geometry. What I could probably do here is take a screenshot, I guess, what I want to. I could take a screenshot of this. and I look at see what's going on here. Alright, so it comes down to visual. Right? It really comes down to visual. 9, 10, 11, 12 is the angles from the diameter subtended to the circumference. 13 is base angles in an isosceles triangle are equal. Them double dash means the lengths are equal. Over here, angles subtended by a diameter to the circumference are equal. Over here, we have diameter subtended to the circumference again. Over here we have the chord AD subtended to C and B. Yeah. Over here I have DC subtended to B and A. You could draw in an imaginary chord. Please don't be afraid to add in a piece of information as long as it makes sense. As long as it makes sense. Alright, so you can take a screenshot of this and attempt these questions. Let me see what else somebody wanted something else. Direct and inverse variation. So I just going to tell you all what to do for direct and inverse variation, right? Direct and inverse variation is a giveaway 3 marks. Giveaway 3 marks, like a giveaway. Right, so I just go in and tell all you what to do, right? Let me get this worksheet. Yes, now again, the worksheet for variation. Variation. Okay, cool. Yeah, we could work with this now. Variation. Perfect. All right. So in variation, you have 2 types of variation: direct and inverse. And at the end of the day, we're gonna change everything to direct. So if I have x is directly proportional to y, you'll have x is directly proportional to y. If I have x is inversely proportional, I will use 2 different letters. If I have p is inversely proportional to q, to change this to direct proportionality, flip this one. Just flip it. So p will be directly proportional to 1 over q. That's it. At the end of the day, we're working with direct proportionality only. Every single time is the same thing over and over and over again. I don't want to work with the proportionality sign. I want to work with an equal sign. So to get rid of it, x is equal to y, and I have to add in a constant k. Hello, can you see that? Come on, man. I watching it on my phone and I could see everything on my phone house. Brijesh Mara. Ismail, what you seen? Alright. We want to get rid of this proportionality sign. So to get rid of it, put an equal sign and add in k. Same thing on this side. P will be equal to k over q. All the time. So let me do this question here. C varies directly as A. C is directly proportional to A. And I want to change, I changing it one time. C is equal to KA. Next one. X is jointly proportional to Y. I wouldn't get things like this, jointly proportional. I'll leave that out. Right? W varies inversely as X. W is inversely proportional to X. I do like inverse, I like direct. W is directly proportional to X. I do like proportionality, I like equal. W is equal to Kx. So to get rid of the proportionality sign, we multiply by K and put an equal sign. In proportionality questions and variation questions, they will give you a condition to calculate K. In this case here, A varies directly as B. So A is directly proportional to B. I do like that. So A will be equal to KB, and they will give you conditions for A and B. They say A is 15 and B is 5. Find out what K is. 15 divided by 5 is K. K is 3. Rewrite your equation. A is equal to 3B. Rinse and repeat. Number 12. C is inversely proportional as D. I do like inverse, I like direct. C is equal to, not equal, direct. Directly proportional to 1 over D. I do like proportionality, I like equal. C is equal to K over D. They give me a condition for C. C is 7. They give me a condition for D. D is 4. Cross multiply. 7 4s are 28. Rewrite the equation. C is equal to 28 over D. So I'm gonna pull some questions how it has actually come. Yeah, next year. All ready for it. All ready for it next year, Ismail. All ready for it already, Ismail. Come on. You know we don't play. You know we don't play that at all. Alright. So I'll show you one, I'll show you all. So what's going on happening now, fellas? Another proportionality question, an independent proportionality question here. Questions like this will come for your exam. The table below shows corresponding values for P and R. P varies directly as R cubed. So P is directly proportional to R cubed. P is equal to K R cubed. The table gives me conditions for P and R. I'm looking at this condition here because I get numbers for P and R to substitute to find out what K is. P is 4, R is 2. 4 is equal to 8K, and K is equal to 4 over 8, which is a half. So P is equal to a half R cubed. Next, they'll want us to calculate M and N. So this here is your bread and butter now. This, good Lord. This here is your bread and butter. That is what you're using now to calculate M and N. When P is M, sorry, replacing P with M, a half, R is 0.2 cubed. Punch is in your calculator. A half, 0.2 cubed. 0.004. Next, P is 62.5, is a half, and R is N. Multiply both sides by 2. 125 is N cubed. Cube root both sides. We get N is equal to 5. And that's variation in a nutshell, guys. I'm gonna put one more to do, right? We have direct. Do I have an inverse one here? Why don't I have an inverse one, man? has an inverse one here. I'll use this inverse one. Right, we pull this one from the archives for us. Given that y varies inversely as x squared, so y is inversely proportional to x squared. Don't like inverse. Directly proportional to 1 over x squared. Don't like direct. Equal to k over x squared. They will give my condition. Y is 3 when x is 2. Y is 3 when x is 2. 2 2s are 4. Cross multiply. 4 3s are 12. Rewrite your equation. Y is equal to 12 over x squared. Calculate the value of y when x is 3. So y is equal to 12 over x is 3. Y is equal to 12 over 9, which is equal to 4 over 3. That is it for variation. That is it for variation. Our next man jump out and say the untitled vectors. Alright. The untitled vectors. I pull the vectors there. Now, you all can pause the video and are going through the vectors fully. Alright, because I really can't make the vectors back and boil it down. I'd rather go through the vectors fully. Right, and then we'll do some past papers for the vectors. Alright. Alright, so apologies for the zooming out and in, but sometimes you can't help it, right? You got to work with that, right? What the hell? Oh, all right, makes sense. I'll move my. All right, so xy is the general form of a point on the xy plane. However, in the vector plane, x is replaced with I and y is replaced with g. So in the Cartesian plane or the xy plane, we have xy. In the vector plane, we have I and g. A vector coordinate could be given as I comma j, just like a regular coordinate, or ai plus bj, or in column form ij. So if I were to give you an example here, a is a vector, 2, 6 is one way to represent the vector, 2i plus 6j is another way, or 2, 6 is another way. Draw the vector, bam shot, just like how you'll plot a point on your coordinate plane, but your vector is an arrow from O to A, where O is the origin. When we add and subtracting vectors, we will add the I components to the I components, and add the j components to the j components. Ismail, go and study up here. Yeah, I's to I's and G's to G's, so you can pause the video and run through these here. Very, very easy. I'll do the first one, OA plus OB. I add in my I's. I add in the I from the OA and the I from the OB. 2 plus 4, and then 6 plus 9. Same thing for subtraction of vectors. I'll subtract the I's and then I'll subtract the G's. We do divide vectors, so we have addition, subtraction, and multiplication. When you're multiplying vectors, it's just like you expand in a bracket. You multiply each term inside by the term outside. So k by ai plus bj is k by ai plus k by bj. For example, 2i minus 11j, 4 by 2i minus 11j, 4 2s are 8, 11 4s are 44. Is it? Parallel vectors comes every year. Parallel vectors are vectors such that one could be expressed as a scalar multiple of the other. And what do we mean when we say that? It means one does look like the next one in terms of its numbers. Alright? Take for instance, AC is equal to 4AB. AC is a scalar multiple of AB. AC is 4 times AB, which means these two vectors are parallel. Now, I want to explain how it could be a little easy to read off a vector, right? Take for instance, right, let me take something here for instance, right? Let me plot some vectors. Origin, here, here, here. I'll draw the vector from here to here, draw the vector from here to here, and I'll draw the vector from here to here. I'm gonna move D a little bit so we could get a little variation in the questions. Good. Now, any vector that starts at the origin is called a position vector. So for example, this vector here is a position vector. This is supposed to be O. So we'll put it as capital O, where O represents the origin, right? Traditionally. So OB, OC, and OD are 3 position vectors. A vector is determined by the path it takes to reach to the other vector. For example, from O to A, I am moving 1, 2, 3 units to the right, 1, 2, 3, 4 units up. So my vector OB will be 3, 4. OC will be 1, 2, 3, 4 units to the left, that will be minus 4, and then 1, 2, 3, let me put 5 units up, 5 units up. So minus 4, 5 will be the vector for OC. OD is 1 unit to the right, which is 1, and 1, 2, 3, 4 units down. Now sometimes you have to calculate these things called resultant vectors. A resultant vector is a vector from B to C. Make life super duper easy, just count it. If you have a diagram, count it. From B to C, I'm moving 1, 2, 3, 4, 5, 6, 7 to the left, which is minus 7 in a vector form, and 1 up. So minus 7, 1 is going to be BC. BD is going to be 1, 2 to the left, which is minus 2, and then 1, 2, 3, 4, 5, 6, 7, 8 down, which is minus 8. Minus 2 minus 8 will be the vector BD. If you don't have a diagram and we have to find out the resultant vector, and we have to find out the resultant vector. The resultant vector is calculated if I want AB. Brother man, I'm going to start with A and end with B. Start with A, end with B. And the letter in the middle has to be the same thing that is common in both vectors. So in this case, it will be O. If I want to calculate the vector BC, that's going to be BC is B something plus something C, and the something must be the vector similar, common in both, and the letter common in both vectors. The letter common in B and C is O. So it's BO plus OC. Every single time we don't have BO, we have OB, they'll give you it. It'll be minus OB plus OC. It's difficult to go through vectors in full in such a short space of time. Unit vectors just come all the time, and in order to know how to calculate a unit vector, we need to know how to calculate the size of a vector. The size of a vector is calculated by just square rooting the I component squared plus the j component squared. So for example, if a vector is 3i plus 4j, it's the square root of 3 squared plus 4 squared. If I have w is equal to 16i minus 2j, this is the symbol for the size of a vector, just 2 lines. The square root of 16 squared plus minus 2 squared. Look at that on a calculator, you go get a number. That's how we calculate the size of a vector. A unit vector is calculated by calculating the size and just putting the original vector over the size. So the unit vector is given by a hat over it. So w hat is going to be the unit vector. It's going to be the vector over the size of the vector, which would be whatever this number will go to be. So let's actually do our question down here, right? A is 3i plus 4j. We already calculated the magnitude of 3i plus 4j, which is 5. So the unit vector a hat is a over the size of a. A is 3i plus 4j, and the size of a is 5. You could leave it like this if you want, or you could separate the I terms and the j terms. That is how to calculate the unit vector. That is it. Super easy to calculate unit vectors. You just know when to resultant vectors. As I scroll along, you can probably pause the video and see what I'm doing. Alright, so I wouldn't scroll along too fast. I would just now say that parallel vectors are vectors such that they are a scalar multiple of one another. I'll just go in and show you all the process to calculate if vectors are collinear or not. Sometimes you could see it, sometimes you can't. Alright, so if vectors are collinear and you have a diagram, for example, here, I'll big up this diagram a little bit, right? L, M, and R. I want to show that L, M, and R are collinear, or that they lie on the same line. Please don't draw a line here and say, but you know they lie on the same line. Don't do that. Please don't do that. You have to show it. To show that the vectors lie on a straight line, take all the vectors from the line. So take the vectors from the line, write it down. L, M, and R. At some point in time when you're working, you'll calculate one of these vectors. I can create 3 vectors from this. I can get LM, I can get MR, and I can get LR. At one point in your working, you'll calculate one of these 3 vectors. In our working, we would have calculated, look, we calculated LM. Your job is to now calculate either MR or LR. If they are parallel and they have a common point, it means they are collinear. For example, if LM and MR are parallel, they have a common point M, so LM and R are collinear. If LM and LR are parallel, they have a common point L, therefore L, M, and R are now collinear again. Finally, if MR and LR are parallel, they have a common point R, so M, R, and L are collinear. So we have LM. At some point in the calculations, we calculated LM. Your job now is to calculate either MR or LR. What did we do? We calculated LR. Now, this is the tricky part. When you get two vectors that are on the same line, one will be a scalar multiple of the other. So if they are collinear, LM is lambda LR. Lambda is just a letter that will symbolize a number. It could be 3, it could be 4, it could be a half, it could be whatever. Your job is to put them equal to each other. Calculate lambda in both cases. So I put them equal to each other down here. I expanded this because this now will be scalar multiplication. I get minus 2 lambda u plus 2 lambda v. I put this u is equal to this u, and I solve for lambda. I get lambda is a quarter. For my v component, I put this v is equal to this v, and I get lambda is a quarter again. Once lambda is the same in both calculations, you put this statement here. Once lambda is the same in both calculations, you put this statement. Go in the next one. Pause the video after, go back and watch it, pause the video, and you can see what's going on, right? Again, did they ask? Yes, they asked us to prove that OG and H lie on the same line. OG and H. So OG and H, let me big up this diagram here. I'll small it up just now, right? OG and H. I have OG, I have OH, and I have GH. At one point in time, I would have calculated one of these vectors in my calculation. One point in time. In this case, we calculated OH. So I have OH, I just have to try and calculate what OG is, or calculate what GH is. So what did we do? We calculated OG. So I got OG to be 6 over 5 V plus 3 over 5 U. So part 3 are showing that they are collinear. I put OG is equal to lambda OH, expand out the brackets here, equate the V component, I get 3/5, equate the U component, and I get 3/5 for lambda. Again, once you get that, brother man, you could write your statement that they are collinear. I didn't finish this one. No idea why I didn't write it down. Alright, so again, in a nutshell, there's vectors. Let me see who has had something different for me to do. Transformations. Alright, so transformations. Again, transformations is a big topic. So, because it is a big topic, I could only browse through it, right? I cannot go through it in depth because it is a big topic, and transformations is a huge topic. Transformations is a very, very big topic. How am I gonna do this for everybody? Transformations is a big topic, boy. And the essence of time, here, all you gotta learn it, all you just have to remember it, right? All you gotta understand it. Just remember it. I'm against this in most cases, but we can't fight it right now, right? So, transformations. We have 4 types: translation, reflection, rotation, dilation. A dilation could either be enlargement or a reduction. Enlargement means it gets bigger, reduction means it gets smaller. So a translation is a literal pick it up and move it. How much I move it to the right and the left, that would be the numbers that dictate the translation. If I move it 4 to the right and 3 up, then the translation is 4, 3. If I move it 6 to the left and 2 up, negative 6, 2. 4 to the left and 1 down, negative 4, negative 1, and so on. So right and up is positive, left and down is negative. We have an equation that will dictate transformations when there's a translation. A plus t is a prime. You could pause the video and you could actually go through these notes. These notes are extremely good. All right, I think everything is explained as best as it can be in the notes. The only thing we wouldn't have is me talking over the notes. Okay. Now, see this green thing here? Real important. Reflections, rotations, and dilations are dictated by this green formula here, the green equation. ABCD by the object point is the image point. ABCD is the matrix responsible for a reflection, rotation, or a dilation. So, see this table here? Transformation, the matrix, and the equation. Learn it off. Learn it off. Reflection in the x-axis. This is the matrix. This will be the matrix equation. XY is your image points. Sorry, your object points. X prime, Y prime is your image point for all of them. Learn it off. Learn it off. For example, if I want to know A, the point A is reflected in the x-axis, it will be this multiplied by 2, 1 will give me x prime, y prime. So look at it. A to A prime, it will be the matrix by 2, 1 to give me x prime, y prime. Go and watch the matrix multiplication videos. You'll learn how to multiply these matrices. If you don't know how to do them, you get A prime to be 2 minus 1. Same thing for B to B prime and C to C prime. Again, learn off the equations. You could pause the video anytime in the notes. Right, I wouldn't scroll down any notes quickly. You could pause the video and go through it. The matrix responsible for rotations is this. We have 4 types of reflections here, by the way. 4 types. We have 1 type of rotation, same exact concept. Alright, they'll give you the angle of rotation. Just note, this is for clockwise rotation about the origin. So 90 degrees clockwise is 270 degrees counterclockwise. Oh, sorry, this is for counterclockwise about the origin. So if they give you a clockwise rotation, just change it to counterclockwise rotation. So if they say something was rotated 45 degrees clockwise, then 45 degrees clockwise is 315 degrees counterclockwise, and that will be theta. So again, you could pause the video here. It has a question here. You can pause the video and check out the working for it from A to A prime, B to B prime, C to C prime to see how we get the object points. Okay, please pause the video. You'll have to describe rotation. Sometimes when you're describing a rotation, you have some important things you have to state. Angle of rotation, center of rotation, direction of rotation, whether it's clockwise or counterclockwise. Now, when you're calculating these things, sometimes you'll have to draw diagrams, and construction is important here. You'll have to bisect lines. Alright, so you can, those are the steps for calculating the center of rotation. Connect a point to each image, at least 2 points. Bisect each line. Extend both bisectors until they cut each other. It could be up or down. and where they cut each other, that's the center of rotation. Alright guys, give me 1 second, right? Give me 1 quick second. Yeah, yes. If you are need help with long division, I am. Me, I believe that. Make sure that right for that. Last minute, no type of it. Right. Yeah, so follow your steps. Follow your steps. Last thing you need to know for transformations is your dilations. Dilations kind of tricky. If I multiply the shape, the size of a shape by a number, then I expect to get a bigger number. So for example, if the size of a shape is 4, and I multiply that 4 by 2, I get 8. That's an enlargement. So once a shape gets bigger, it's an enlargement. If a shape gets smaller, it's a reduction. And the enlargement and reduction, it is dictated by the scale factor called K, where K represents a number. Now, you might think, well, if K is negative, well, that's a reduction. But you'll be wrong. And this is where it takes a little while for your mind to wrap around it. Focus on the number. Ignore the sign. If k is more than 1 in terms of the number, is an enlargement. If k is a fraction, it is a reduction. So k can be -6. That is an enlargement. Focus on the number. Ignore the sign. K can be -12. That's an enlargement. But the minus sign has a part to play. If k is 14, that's an enlargement. If k is -1/2, that's a reduction. If k is 1/4, that's a reduction. The part the negative sign plays is the side the image is on. So if you look here, in the first diagram, k is 0.25. Second diagram, k is 0.4. Both cases, k is a positive number. When k is positive, the image and the object are on the same side of the center of enlargement or the center of reduction. Look at this diagram now. You can read the notes running after. Center of dilation or center of reduction is here. Object, my first image, k is plus 2.5. So the image is on the same side as the object. Second image now, k is -2. It's an enlargement. It is an enlargement, but the enlargement is on the opposite side of the center of enlargement. That's the only part the negative sign has to play. To calculate k is object length, image length over object length. That's super easy. This be used plenty. Real plenty. The area of our image over the area of our object is k squared. So important, real important. I could see it coming for exams. Area of the image is k squared times the area of the object. So again, go through your notes. Go through the notes here. Pause the video and go through the notes. Ronaldo, why? Ronaldo Mohammed. So what are big now, huh? Last call. I locked it off 9 o'clock. What else all I want to go through? All that 8 minutes. 8 minutes of my time. For paper 1, fellas and ladies, as soon as you do a question, double check it. Alright? As soon as you do a question, double check it. So shoot. As soon as I get the paper, I'll be doing the solutions tomorrow night. As soon as I get that paper, it's solutions time. Yeah, we don't play. As soon as that paper reach, brother man, peace. Kishanta says she wants some tricks. For enlargements, we multiply each point by the scale factor. Yes, you could multiply each point by the scale factor, but there is a there is a matrix that is responsible for that. Let me show you the matrix responsible for that. For I have it here. Yes, no? Let me get that fair. There is a matrix responsible for that. Strange, it doesn't. Not any notes. Oh shucks. Forget one thing. Don't be frightened, Gil. Just try your best. I'll give you some advice after. Combined transformation is important. The notes will say it all. So pause the video and go through the notes. This highlighted piece here, Ronaldo, is the matrix responsible for enlargements or reductions. So it'll be the matrix multiplied by an object point will be equal to an image point. The K is a scale factor. K can be positive or negative, whatever K is. Right, so we all can go through this here. Just remember, if I have A passing through M, then passing through N, the combined transformation will be N then M. Please, I can see this coming as well, especially in a multiple choice. So please go through this. Right, the notes here are self-explanatory. I can't get better than these notes explaining combined transformations. It's extremely easy, and you have a good example here. A real good example here. Again, if you need to know how to multiply the matrices, go and watch the matrices video. Right, so trig, somebody said trigs. Now, trigs is, Shanta, you still want trigs or say you delete the messages? I don't know what you want to do. I have 4 minutes to run through trigs here. I'll just go through the notes as per usual. I'll just go through the sine and the cosine rule. Alright, so sine and cosine rule. Non-right angle triangle, there are two rules. So the sine rule is A over sine theta is B over sine alpha is C over sine beta. Now, how do you know the angle on the side? It's always the side opposite the angle. Alright, I think I have a better one for this. I actually have a better one for this. Yes, I do. I definitely do. Yes, I do. Good. Alright, so my sine rule, aiming. The side must be opposite the angle. And that's the pairs we use. Right? A over sine alpha, B over sine theta, C over sine beta. Right, when you use the sine rule, pick either 1, 2, 1, 3, or 2, 3. The pair selected must have one unknown. And just rearrange to calculate your unknown. So we have the 1A with solutions, go through it. 1B with solutions, go through it. 1C with solutions, go through it. 2A with solutions, go through it. 2B with solutions, go through it. And 2C with solutions, go through it. Alright, you have plenty of examples here. You're bound to pick it up. I tell you, you're bound to pick it up. Cosine rule similar. The side you start with must correspond to the angle you end with. And it's a pattern. A squared is b squared plus c squared minus 2bc cosine a. The side you start with must end with the angle. So b squared is a squared plus c squared minus 2ac cosine b. Or c squared is equal to b squared plus a squared minus 2ba cosine of c. Again, you have an example here. Go through it. When you use the sine rule, you'll have to resort to the cosine. When you use the cosine rule, you'll have to resort to the sine rule to finish it off. So I have an example. Go through it. You have another example here. Go through it. Right. I wouldn't say the most necessary, but you get formulas that you will have to use in the exam. Probability in a cumulative frequency curve. All right. So when we talk about probability, I will just talk this one. This one's super easy. When we talking about probability in a cumulative frequency curve, on a cumulative frequency curve, you can only calculate probabilities regarding the less than sign. So if they ask for a probability of less than, you will look at where that is in the cumulative frequency curve or the cumulative frequency table. So let's say the probability that x is less than 14. You're looking for when x is less than 14, adding up all the numbers before 14 in the cumulative frequency table and putting it over the total number of people in the population. If you want to calculate the probability that x is less than 20, look for 20 in your cumulative frequency table, add up all the numbers before 20 over, no, I lie, that add up all the frequencies before 20 and put it over the total, calculate your probability. If you have to calculate the probability that x is less than 45, it will be, you're going in it and you have the curve, you're going in the curve, you're looking for where 45 is. Let me see if I have an example here. I like talking it out. Statistics. I have one. Just one example. You draw a cumulative frequency. You want to know the probability that x is less than 40. It'll be 1 minus the probability that x is greater than or equal to 40. On my cumulative frequency curve corresponds to, I'll zoom in here a little bit. 40 will correspond to, oh god, no. 40 corresponds to looking like 10. So less than 40 is 1 minus greater than 40 or equal to, which will be 39 over 40, because here will be looking like what, 11 over 40. 11 over 50, because the population is 50. If this is 11 over 50 here, let me go to the question. Which question was this? Can't remember which year this was. I don't want to confuse you too much, right? Let me look for a question with a particular year. Alright, we start over, Ronaldo. For a cumulative frequency curve, when you're calculating probabilities, I make a mistake. You could only calculate probabilities. You could only read off probabilities greater than or equal to. So if a question gives you a probability less than, it's 1 minus the probability of greater than or equal to, in a case like this here. So the probability that x is less than 40, you're looking for 40 on your cumulative frequency curve. Now, let me say this curve represents students. Your students would be on your upper class boundary scale. So you're looking for 40 on the upper class boundary scale. You're going up, you're going across. That would be 40 is greater than or equal to 40 will be 1 minus 39 over 40. Because when I go up to 40 and I go across, I get 11. And 50 minus 11 is 39. I need the context for this question to explain it properly. And I don't think I have. Wait. 2020, don't I have 2022 solutions on this channel? Let me check. I think I do, Ronaldo. Ah, shit, I didn't do 2021 solutions. Shit. Right, I got any question here just now. All right. So the question stated, calculate the probability that a student chosen at random has at least 12 correct answers. Now, at least 12 correct answers, that's the least amount of answers you could have. So at least 12 will be 12 and more. At least 12 is going to be 12 and more. So you can actually count it on a cumulative frequency curve. You're looking for 12 on the upper class boundary and see how much people have more than 12 marks. Or you're checking and see how much people have less than 12 marks from an upper class boundary when they go across. That's how much people have 12 marks. Because it's a cumulative frequency curve, that number, when you go up and you go across, that number will be everybody who have 12 marks and less. Right? So everybody else go have 12 marks and more, and the probability will be that number, this number here that you're reading off, over the total number, 1 minus that. Right? I hope that makes enough sense for you. I hope it makes enough sense. I so vexed I didn't do the solutions. All right, some tips for the exam. When you get your paper, go through all your questions on your paper. It's okay to take 5 minutes, read through number 1, read through number 2, read through number 3, and so on. Do the questions you can do first and foremost. Do the questions you're comfortable with. If you know you're strong in trigs, look for your trigs question and do it first. If your number 1 says using a calculator, you can just write down your answer. Plug it in a calculator, write down your answer. You'll get your full marks. You have to answer all your questions in paper 2. Don't waste time trying to be neat in the beginning, please. Because bet your bottom dollar, if you go in and take your time, draw a nice little working column, work out your working, don't waste your time. If you want to draw a working column, scribble a little line. For example, scribble a little line here and do your working here. You don't have to go and pick up a ruler, pick up a pencil and draw it. Right? Please do that. In your paper 2 exam, feel free to ask for a piece of paper to do working on, to do scrap working on. Alright? Please. Don't afraid to ask for a paper. The invigilators, they're supposed to give you a paper. Supposed to. If they don't give you a paper, then they're doing something wrong. If you ask for extra paper, you're entitled to that. Do you working on an extra piece of paper? Submit all your working. All the paper, everything. Please, if you make a mistake, do scratch it up and thing. If Luke watching this, Luke, please don't scratch up your work. Draw one line through it. That is it. Don't scratch up your work. It's easy for an examiner to find marks they give you if your working is neat and in order. The number of marks on a question should give you an approximation as to how much time you should spend on that question. I don't know. So if our question is with 3 marks, spend at least 3 minutes on it. If you work like that, sometimes you will go over the 3 minutes. That's okay. Don't pressure yourself because a question is with 5 marks. You expect, okay, I have 5 minutes to do this. Some questions will be worth 1 mark and you will finish it in less than a minute. So it's a give and take. Right? For your paper 1s, as soon as you do a question, check it over. If you do that, at the end of the paper, you don't have to go and check over your work. If you do check over your work at the end, I've seen it happen. Students start double guessing themselves. I want to have this correct. No, this can't be correct. It had to be that one. And they changed the correct answer and put another answer. Somebody take your time now, gosh. Relax. Now, I'm sorry I didn't do more lives with all you before, but I was a busy man. Can't find that. But I hope I helped at least one person here tonight. How many questions? I think it's 10 or 11 now. Seven and 3, 10 questions. Right, 10 questions in all. Right, I see somebody here. It's okay if you use n+1 for your quartiles, please. n+1 is, you can go ahead and ask questions, Jordan. Big up yourself. n+1 is a more approximate, a closer approximation to just n. Right, so please use n+1. Jordan, if you wanted to ask a question, I will turn out until your question has been answered. Alright, good job for good job for all those who did well in their paper 1 and 2 in English today. Very good job. I heard there was one essay on environment that gave a lot of students some problems. Hopefully none of you all experienced that dilemma. My SB is 14 over 20. It's possible to pass my teacher. Yes, boy. So your SB is about 20% of your final mark. So that you going in the exam with 14%. So brother man, if in your exam you make at minimum 36%, you're passing. On the mathematics paper 1, you could do anything you want on that paper. You see a multiple choice answer sheet, shade your answers completely. Don't put anything else on the answer sheet. Don't do no working on your answer sheet. Do your working on the booklet that have the questions in it. Alright? So Jordan, whoever your teacher is, he or she lie. A man could get 0 in the SBA and still pass. Alright? It is possible to get full marks in paper 2 and not do so hot in paper 1 and still pass. That was your question, Jordan. Kiran, I just now answered that, Kiran. Use the n+1 in your quartiles. Use it. It's a better approximation. Can I get a 1? I'm going to do 2021. Yeah. Your SBA is worth 20%. So if you get 20% out of 20%, you're going in the exam with 20% already. Last second English, sorry, last line. Nice small thing. If you get 70% in the SBA, 38 out of 60 in paper 1 and 20%, yes, you can pass. As long as you can muster 50%, you can pass. Now guys, plain talk bad manners. 3 is a pass, 2 is a pass, 1 is a pass. If you know that you're strong in certain topics, tackle them topics. You don't have to get full marks in paper 2 or full marks in paper 1 to pass. Just prevent yourself from repeating. Answer that just now, Kareem. You can write on the paper, the physical paper itself. Do not write on the do no working on your answer sheet. You'll have an answer sheet, do no working on that. What paper to focus on? Paper 2. Paper 2 is worth more. We want grade 1's not pass. I agree with that. I like that kind of mentality. It's always good to have. Now, this live will be available for you all to watch after. So please go back, watch it, go through the notes if you all need help with anything. Watch the matrices videos. There's a remedial playlist for those who are really struggling, especially in coordinate geometry. It has a good playlist on coordinate geometry explaining everything. Go through it. It has the matrices videos. Now I will be paying emphasis on those AdMath students. the AdMath students, I will be doing more videos, more lives like this, answering questions for AdMaths. So AdMaths is next week Wednesday. I could probably tackle 1 question a day or 2 questions per day in terms of topic. So I could do functions in one day and probably APs and GPs in one day and so on. So if you all doing AdMaths, feel free to jump in, ask questions. You all can also leave comments underneath this live after the live is ended, and it actually goes out to the public for you all to watch. You all can leave comments underneath it on your thoughts, your opinions. Be respectful, please. Be respectful. Any questions for those AdMath students? Feel free to put them downstairs there, right? Feel free. Alright, I just scrolling through the chat here. Yana, go aim for just 30 naman. Aim big naman. Come na. Aim bigger than that. Minimum mark you can get in paper 1. Brother man, the minimum mark you get in paper 1 is 0. Come on, bro. 0 horse. If you have 20% and I'm very good in paper 1, then you're on the right track. You're on the right track there, Kareem. No, you can't use calculators in paper 1, unfortunately. Not around. Me, I'm going to do anything else for the night. Next week, Tuesday, for the with Nikolai. Alright, so the nerves. A lot of people will have the nerves going into an exam. If you're confident in your abilities, walking the exam with your head high is a mental thing, right? Walking that examination with your head high is a paper. Don't let no paper make you feel small. Don't let no paper make you feel like a imps. Please. It's a paper. You had to just mash up. Alright? If you know you're good at it, just do your work. Go in the exam and mash it up. Do the questions that you are comfortable with. Because if you bounce up a question that you're struggling with, you're gonna feel defeated. That's why I recommend always do the questions that you're comfortable doing first. Alright? We need to know n factorial for paper 1. No. You can't use calculators, Miss Rain. You can't. Hard luck. Hard luck. That is a tough one. Yeah, gee, no calculators for paper 1. I want tough. But, oh, shit. And then if you forget to show you something, Jed. Let me show you that thing here for paper 1. For any paper, right? I mean, it might seem like small thing, but it does make a difference. It will make a difference. When you're adding 2 fractions, let me say you had to add a half. Let me do this half. 5 over 11 plus 2 over 7. When you're adding them 2 fractions, you know you wouldn't be able to do this in a paper 1, on a calculator. LCM, no problem. An easier way to do it, multiply here. 7 5 is 35. multiply here, 22. Keep the sign in the middle, all over, multiply here, 77. Add the numerator, 35 plus 22, that is what? 57 over 77. If it could be reduced, reduce it. The reason I'm showing you this, in paper 1, you'll have algebraic fractions. An algebraic fraction looks something like this. 2 over x plus 3 over 7. And you'll have to simplify. When you simplify an algebraic fractions like this only works for 2 fractions, guys. Multiply here, 14. Multiply here, plus 3x. All over, multiply here, 7x. And that's as simple as it gets. Another trick, when you have to square a bracket, 2x plus 3 all squared, square the first term. Square the last term. Multiply the two terms by each other and then multiply it by 2. So that is 3 2s are 6x. 6x by 2 is 12x. 2x squared is 4x squared plus 12x plus 9. Y plus 4 all squared. Square the first term. Multiply the two terms by each other, 4y, and then double it. Square the last term. Square the first term, 3x all squared is 9x squared. Multiply the two terms by each other. 3 by 2 is 6, x by y is xy, minus 6xy, and double it, minus 12xy. Square the last term, 2y all squared is 4y squared. Alright, but the fraction trick, top tier, you can't go wrong with that. You cannot go wrong with that at all. Yeah, Miriam, don't fight up yourself. You will do well. Everybody will do well. Right, it's just a shame I didn't have more time to spend with you guys to help you all out. On that one, I guess that one is on me. I should have made more time. But don't worry. Don't worry. For those who are doing ad maths, I'll put things in place for ad maths. For those who are going to do pure maths and stuff next year, I'll put things in place for pure maths and stuff next year. Right? And in the event that you'll have to, I don't want nobody feel discouraged. If you had to repeat it, check me. Check me. Give me a year with you. Check me. Distinction. 100% distinction. Even if you want to do over maths, let me say you got 2 on your way, distinction. Check me. Distinction down the road. That's all we the same for here. Distinctions. Right? So guys, good luck. Burn the midnight oil. Study your work. If you had to lose a night's sleep to do your work, go ahead. Do it. I did it already. If I could do it, all I could do it. Right? All I could big up all yourself. After the exam tomorrow, I don't know where's the next exam after maths. But relax all yourself. Go in all the exam confident. Given that you all are here right now, means you all are interested in passing your exams. Alright? So big up on yourself. Yes, Aidan. Yes, Aidan. Big up on yourself. Organize all your protocol. Make sure all your calculators have battery in it. Alright? I doing one for AdMath starting from tomorrow, Aidan. Don't fight up yourself. Right? Well, if I get the paper, I'm doing the solutions tomorrow. Thursday, I go start AdMaths. Make sure the calculator have battery. Make sure the pen have ink. Make sure the pencil have lead. Make sure your rubber good and working. Make sure you have a sharpener. Make sure you have all the utensils. Please work with your geometry pan. Don't ask to borrow nothing in COVID. Right? Nobody want to get COVID. So please, fellas and ladies, big up all yourself. Hopefully I'll see you guys tomorrow as long as I get the paper. If anybody gets the paper, please send it to me. Send it to me. Send it somebody. Before I get the paper. Send it somebody. If anybody spam calling man thing, I'm blocking you. If you messaging me, well, feel free to hit my message. If you're getting problems with a particular question, feel free to message me. I'll respond with a voice note. Alright? Once I am awake, I will respond with a voice note. If you're asking me to go explain a whole topic for you, I have time to do that. I'll help you with questions. Okay? There's also solutions on fastpassmaths.com. Full solutions for all papers. Alright? Worked solutions. But if you need an explanation on something, feel free. Okay? Feel free to message. I will put the navigate to this website, navigate through it, and you'll see the solutions for the maths past papers. Only paper 2s, no paper 1, unfortunately. Yes, you need a geometry pan. Alright, so Aidan, Harmony, Joel, Carissa, Rajiv, Aidan, Miriam, Nikhil, you could me calling you Nikhil. Anu, Miss Rain, everybody who here, Terrell, Ishanta, Kareem, Ronaldo, Ishwar jumped out in the beginning, Joshua, Gerard, all them boys in Form 4, big up on yourself. Alright guys, so that's it. Good luck to everyone tomorrow. I'll do the solutions for this paper tomorrow, and I'll see all the AdMaths people from Thursday. Alright guys, so enjoy, good luck, I'll see you guys soon.